Okay. So this morning we are privileged to have Dr. Hugh Ross, who's going to give a presentation on climate change. And so the topic is climate change for real, and what can we do about it? So the topic is weathering climate change. So how do we react? So just to warn you, he does believe it is real. And is related to human activity, but he has some novel ideas on how it can be addressed without causing huge disruption to human flourishing. So thank you very much, Hugh. Dr. Hugh Ross was an astronomer, astrophysicist at the University of Toronto. He is the founder and president of Reasons to Believe and is the author of over 17 books. I won't list them. And Ross has addressed students and faculty on over 300 campuses in the US and abroad, and speaks at various churches and groups on a wide variety of science faith topics. And so we are extremely appreciative that it's taken the time to zoom in all the way from California. And so thank you very much, Hugh, and I'll hand it over to you.
Well, thank you. And it's summertime here in California.
Okay.
And also I'm speaking to you from yesterday. I think it's Saturday morning for you and Friday evening for us. And looking at Elisa's background, I see you're having an especially cold winter there in Adelaide. So reminds me of where I grew up in Canada. So anyways, let me do share screen here.
By the way, can I just interrupt? If you actually record questions on the way, then please use chat, and then we can actually walk through those questions after he's finished his presentation.
Okay, you should all be seeing my first slide right now. And this is just an indication of how you can contact us. Every one of our scholars at Reasons to Believe maintains a personal Facebook and Twitter page. And we basically use that to answer people's questions and to keep them up to date on the latest evidences for the Christian faith. So if you don't get to ask your question this morning, you can approach me on Facebook and Twitter. And Reasons to Believe does maintain a 24/7 YouTube channel. You can subscribe for free, and that'll keep you up to date on all the latest videos that we upload to YouTube. And the website is reasons.org. And you can get free chapters. I've written now 20 books, and you can get free chapters of my books at reasons.org/Ross. Most of what I'll be sharing this morning comes from this book, Improbable Planet, and a sequel to that, Weathering Climate Change, reasons.org/Ross. And I actually took this photo of my wife in the middle of summer up there in Canada. You get up there in the mountains, you can literally get several inches of snow even in the first week of August. But Canada is being impacted by climate change more than any other nation in the world. Particularly the northern parts of Canada are warming about 5 times faster than the rest of the world. But you do get these days when everything reverses. I mean, my father grew up in Alberta, and he would talk about the Chinooks, where in the course of 1 hour, the temperature would jump up by 45 degrees centigrade. But it also could go down by that much, literally in 1 hour. Okay, weathering climate change. I'm only going to look at a few of the items that are mentioned in my book, Weathering Climate Change, and basically talk about how it is that we happen to have this period of extraordinary climate stability. And this next slide actually shows you the luminosity history of the sun, basically making the point that if you look at the past 3.8 billion years of history of life on Earth, what you notice is the sun right now is warmer or brighter than it's ever been. And for 90% of Earth's history, our planet had no ice at all. And yet today, we've got ice that covers 10% of the planet. Matter of fact, we are in an ice age cycle. And so the real enigma is, with the sun as bright as it is, and with our planet not having ice for 90% of the history of life on planet Earth, how is it that we've got ice today? And incidentally, that ice is crucial for sustaining billions of human beings. We literally depend on the melting of ice left over from the last ice age to sustain the necessary agriculture to feed billions of human beings. And incidentally, the ice age cycle also fertilizes the great agricultural plains. Every time we come out of an ice age, the agricultural plains get fertilized by two different means as a result of the rebounding of the Earth's continents from the heavy load of ice that was on top of them. And so ice age cycles are good, but ice age cycles bring extreme climate stability, as you'll see in a minute. Now, what I'm going to ask of all of you, if you could mute your microphones until I get through this presentation, because otherwise, if you get everybody's microphone live, there's going to be significant background noise. So yeah, if you could, that's in the lower left, you can temporarily mute your microphone. Yeah, thank you. Okay, the biggest factor of all that explains how we happen to have ice with the sun as bright as it is. And you say, well, why didn't God put us here earlier? It turns out that the sun is only stable enough for global human civilization when the sun is 4.57 billion years old. So we humans happen to be here on planet Earth at the one narrow moment when the sun has sufficient luminosity stability to make global civilization possible, but also means we're here when the sun is exceptionally bright. But the biggest factor that transformed our planet from having no ice to having ice was a massive asteroid that hit the Earth in the South Atlantic Ocean. That little red dot represents the collision point, and it landed in a place where there's over 5,000 meters depth of water. And the asteroid was between 1 and 4 kilometers across. So we're talking a really big asteroid. And it went through those 17,000 or 5,000 meters of water, got to the bottom, and caused this massive eruption of sulfur and water vapor aerosols into the atmosphere, and actually blanketed the entire planet with these very hazy aerosols. And this lasted for several years and basically reflected away enough sunlight that it led to a huge buildup of ice over Antarctica and over Greenland, and that began to cool down the whole planet. And this was discovered accidentally by a research ship that happened to be trolling the bottom of this part of the ocean, and they found all these isotopes that they knew could only come from a giant asteroid collision. The other evidence we have is that we see all along the Pacific Rim and even along the Atlantic and even into the Mediterranean evidence for 300-meter high tidal waves running from this spot. And you see this literally all over the world. Even in the Adriatic Sea off of Italy, we see evidence for this massive tidal wave that poured up a huge mud deposit there. So definitely a catastrophic event, but it was beneficial in that it caused enough of our planet to be covered with ice as a result of the cooling from the aerosols that it enabled the ice age cycle to start. And so without this, there would have been no ice age cycle. Now, there's actually a third or a second asteroid that hit. This one hit 2.58 million years ago. And that's what the very beginning of the ice age cycle, where a planet cycles between 10% ice coverage and about 20 to 23% ice coverage. About 800,000 years ago, another asteroid, a little bit smaller, but probably a good kilometer in diameter, hit in the South China Sea, and it actually split apart. We now think this was a giant comet, because asteroids typically don't split apart, but comets do, since comets are about 85% of frozen water. So when they go through the atmosphere, they can break apart. And we've now found a second crater site, and it's in Laos. So over to the left of the slide, you'll see a small elliptical blue dot. That shows you the location of a second collision site. The red dot you see there in the middle of the South China Sea, that's the minimum crater size. Maximum crater size is the outline of the blue. And it hit where the Spratly Islands are located. And previous to 800,000 years ago, these Spratly Islands were big. But as a result of this asteroid, it almost totally obliterated. And now all you have are these tiny atolls that exist there in the South China Sea. And you're probably aware about 6 different nations have claimed those islands and are trying to transform them into military bases. But what this did is it caused a huge cloud of dust and debris to escape from the South China Sea and be spread into interplanetary space. And Earth passes through that every 100,000 years. And what this did is it changed the Ice Age cycle from having a 41,000 year periodicity to a 100,000 year periodicity. And so the asteroid that collided off of the south tip of South America, that's what ignited the 41,000 year cycle. You say, what drives that? What drives that is a changing tilt of Earth's rotation axis. Our rotation axis goes through a cycle of 41,000 years where it oscillates between 24.5 degrees and about 22.1 degrees. And when it tilts over towards 24.5, the planet warms up. When it tilts back towards 22.1, the planet cools. And so for about 2 million years, that drove a 41,000 year ice age cycle. 800,000 years ago, the asteroid that hit in the South China Sea played a role, not the predominant role, but it did play a role in transforming the periodicity to about 100,000 years. This was crucial for human civilization because with a 41,000 year period, that means your warm interglacials, where you only have 10% ice coverage, lasts about 2,000 years. But when you get 100,000 years, you got the potential for the warm interglacial to last 8 to 10,000 years. And actually what's unique about the ice age warm interglacial we're in right now is that we've been in the warm interglacial for almost 14,000 years. So we're actually in the longest interglacial that's existed in the ice age cycle. Now, this next slide shows you that the ice age cycle is typified by extreme climate instability. This shows you the last 4 ice age cycles. And this is the temperature in degrees centigrade. 0 represents the temperature we're at right now. And this just shows you over the course of 100,000 years, the global mean temperature jumps up and down by about 10 degrees centigrade. Now this shows you the rough temperature variations. I'm going to show you a more detailed one about what happened in the last ice age cycle, and actually shows you that the temperature variations are much more extreme than what you get in that average one I showed you in the previous slide. So this shows you the global mean temperature based on ice core drills in Greenland and in Antarctica, and basically demonstrates that when you're in an ice age, the global mean temperature varies by 12 degrees centigrade on time scales of just 1, 2, or 3 centuries, and explains why humans living during the last ice age were unable to launch global civilization. We do see tiny spurts. For example, we now have carbon-14 evidence that tells us that humans living 14,000 years ago, 23,000 years ago, and 36,000 years ago were engaged in bakery industry. They were planting grains, harvesting the grains, roasting the grains, grinding the grains, and turning them into bakery products. But all this was done on a very small scale. Because of the extreme climate instability, humans were forced to cultivate multiple grains. Typically, they would plant 10 or 15 different plant crops on 1 or 2 acres, and they would figure that maybe 9 to 10 of those crops would fail, but they would feed their families on the 2 or 3 that survived. And because of the extreme climate instability, they couldn't predict which crops would succeed and which would fail. Moreover, when you're in an ice age, the carbon dioxide level is a lot lower and was sufficiently low that it actually hindered photosynthetic production. So this demonstrates that humans were just as inventive back then as they are now, but they were hampered by this extreme climate instability. And incidentally, this typifies the entire ice age cycle. Whether you're in a warm interglacial or during a glacial episode, this is the temperature that you see over the entire planet. The only exception has been the past 9,500 years. And so this next slide actually shows you what happened. I mean, that pink curve there shows you the typical temperature changes that occur during an ice age. But what happened beginning 9,500 years ago is for a reason that I'm going to share with you briefly. The global climate stabilized to an incredible degree. And this graph I'm showing you here is new. You wouldn't have seen this 2 years ago, but what has happened is that climatologists have developed a database of 74 temperature proxies. And in analyzing those 74 different temperature proxies, they discovered that over the past 9,500 years, the global mean temperature has been 4 times more stable than what we thought 2 years ago. The old data said the temperature has been stable to plus or minus 2 degrees centigrade. We now know it's been stable to plus or minus 0.65 degrees centigrade. Now, if you look all the way to the extreme right, what you'll notice here, if you look very carefully at the blue line, you can see that it slightly declines. The global mean temperature over a 9,000 year period cooled by 1 degree centigrade. But over the past 70 years, it's warmed by 1 degree centigrade. So today in 2020, we're at the same temperature that the Earth was 8,700 years ago. And what's driving this global warming debate is if this 1 degree increase that we've observed over the past 70 years continues, that could cause the global mean temperature to go up to its typical maximum. Now, if I take you back a couple of slides, this shows you that in previous ice age cycles, the global mean temperature quickly rises to a peak that's about 2 degrees centigrade above where we are right now. And when it hits that peak, it reverses and quickly drops us back into an ice age. And so it kind of shows you the unique picture, because what's happened in this particular ice age, instead of the temperature quickly rising up to a peak and quickly dropping us back into an ice age, instead it stopped short of that peak by about 3 degrees centigrade and plateaued for 10,000 years. Now, what's responsible for that plateau is that when you see the temperature dropping from a peak, that's driven by the variation in Earth's orbit about the sun and the tilt of Earth's rotation axis. Our rotation axis is now tilting back towards 22, and the shape of our orbit around the sun is becoming more circular. Both of those effects cool our planet. And if it wasn't for human activity, we'd be deep in an ice age right now. What has happened for the past 9,500 years is that the natural cooling driven by these cooling cycles has been perfectly counterbalanced by warming as a result of human activity. Basically, what happened is 9,500 years ago, the climate briefly stabilized. Humans took advantage of that to scale up their agriculture, to domesticate cows, and the chickens and other creatures begin to cultivate rice. And that began to warm the planet, but warmed the planet to the same degree that the natural cycles were cooling it. And that's been in balance until 1950. And that's mainly what I'm writing about in the book, is all the amazing design features where we have the natural cooling actually being counterbalanced by human activity. Net result being we got this long period of extreme climate stability. But what I want to share with you is what happened that stopped the global mean temperature from rising to its normal peak of 2 to 3 degrees centigrade above where we are right now. You can see dotted lines showing that there was an event. It's called the Younger Dryas cooling event, where the temperature drops by about 10 degrees centigrade over a 1,200-year period. And until about 2 years ago, there is a mystery as to what caused this cooling event. The cooling event showed up on all the ice core records, but what caused it was a big mystery. Excuse me, I have asthma, so I got to deal with that. And I have a chapter in the book describing the recently discovered event that explains the Younger Dryas cooling. But this cooling basically prevented the global mean temperature from rising up to its normal peak, actually enabled a brief period of climate stability to come into play, which was responsible for the launch of human civilization. And what happened was a NASA aircraft was flying over northern Greenland and happened to have its deep penetrating radar operating. And as it flew over northern Greenland, it found an anomaly. It basically discovered a crater about 3,000 feet underneath the glacial ice of northwest Greenland, in the region called the Hiawatha ice field. And this shows a blowup of the area. That little red circle represents the crater. And again, they discovered that this must have been an asteroid about a 1.5 kilometers in diameter that punctured through 3,000 feet of ice and caused this crater below the ice. Now, there was some previous evidence for this, because what we have been noticing is that long before Europeans came to North America, the Inuit people in northern North America, would visit this site, and they would collect pieces of stainless steel. A quarter of the asteroids in the asteroid belt are basically pure stainless steel, actually a better grade of stainless steel than what we manufacture in our steel mills, very rich in cobalt and nickel. And so the Inuit would grab up these pieces from this region in Greenland and bring it back to their area, and they would use cold pounding techniques to make tools. And so the Inuit people had very sophisticated tools that were basically pure stainless steel as a result of this harvest. But what happened after the NASA aircraft found this crater, geophysicists went to the site, and they went to just the edge of the ice field, and were analyzing the meltwater coming out of the glacier, and discovered it had the isotope signatures of a giant stainless steel asteroid striking that area. Okay, the next slide shows you Lake Agassiz. The lake doesn't exist anymore, but this lake was there about 15,000 years ago, and was a lake of glacial meltwater, basically a gigantic lake filled with meltwater from the receding glaciers over the Canadian Shield. And it drained down the Mississippi into the Gulf of Mexico. And when this asteroid struck northwest Greenland, it basically caused huge amounts of ice and rocks to pelt North America, particularly Canada and northern North America. In fact, we've now found evidence of these giant rocks that bombarded Canada and the northern US as a result of that asteroid collision in Greenland. But what it did is it blocked the flow of water going down the Mississippi into the Gulf of Mexico. And it opened up two more channels of drainage, one through the Great Lakes and out through the St. Lawrence River, and another one that went out through Athabasca Lake, Great Slave Lake, and a Great Bear Lake into the Beaufort Sea. And what happened is this caused a flow of cold glacial meltwater to go up the St. Lawrence and dump into the northern Atlantic. And in the Beaufort Sea, there was a current that drove this cold glacial meltwater over towards Greenland, in between Baffin Island and Greenland, and actually joined the cold meltwater that was coming out of the St. Lawrence River. And this turned back the Gulf Stream. And that wound up cooling all of Europe and led to a deposit of a cooling event all over Europe, Siberia, North America, Alaska. All those were significantly cooled the rest of the earth. And that actually stopped the temperature from going up to its normal maximum. Excuse me. Now, the reason why you see in the Ice Age cycle that when the global mean temperature rises to about 2.5 degrees centigrade above where it is now, we go into a deep ice age. It's because that global warming melts the polar ice cap. And when you melt the polar ice cap, instead of the Arctic Ocean reflecting sunlight with 60% efficiency, the ice melts, and now you got open ocean liquid water, which reflects sunlight with only 6% efficiency. And what happens to all that extra absorbed sunlight is it makes water vapor over the Arctic. And that water vapor falls as snow over Canada and Siberia. The only reason why Canada and Siberia are not covered by thousands of feet of ice today is that they don't get enough snowfall. They only get 10 inches of precipitation equivalent per year. Let me see, I need to convert that. That's about 20 centimeters that you would get per year, a little more than 20 centimeters. And Canada and Siberia are plenty cold enough for ice to build up, but they simply don't get enough snow. But when you melt the polar ice cap, in spite of the warmer temperatures, snow quickly accumulates all over Canada. So that's the enigma. Global warming always brings on global cooling because of the increased snowfall over North America, Europe, and Siberia. But this flow of cold water blocked the Gulf Stream and prevented the polar ice cap from melting. And so that brought us this period of extreme climate stability. And it's because of that extreme climate stability that we've been able to launch global high technology civilization and build up the human population literally into the billions. And this is actually referred to in the book of Revelation. The book of Revelation, chapter 7, verse 9 says that there was a great multitude that no one could count from every nation, tribe, people, and language, referring to the multitude of the redeemed that will be receiving their new bodies in the new creation. Basically making the point, there's going to be billions of human beings that will be redeemed. I get that number from the fact that when this was written, the Greeks had a number system that went up to 1 billion. So when it says it's an uncountable number, that means it exceeds 1 billion individuals, which means that it was God's intent that we'd be able to have sufficient climate stability that we could bring our population up into the billions of individuals. So the billions of us could be redeemed. Evidently, God intends that the new creation is going to be filled with a large population of human beings. But that requires this extreme climate stability. Now, I want to spend the last few minutes I got here before I open up for questions. Yes, global warming is real. The temperature has gone up by 1 degree centigrade. If it goes up another 2 degrees centigrade, we will melt the polar ice cap. When we do that, we'll bring on the next ice age, and with it will come the return of extreme climate stability, and we're going to require a dramatic drop in the human population. But a lot of what I put in the book, in fact, a lot of people tell me it's the anti-Al Gore book. Most books that are on, in fact, every book I know on climate change is basically making the point, climate change is real. We got the temperature records that prove that it's real, but they're saying that in order to stabilize the climate, we have to make substantial economic sacrifices to bring that about. They're overlooking a biblical principle, two biblical principles. One biblical principle is that we human beings are all sinners and we're fundamentally selfish, and therefore trying to get the entire population of the world to lower their standard of living by a factor 2 or 3 times isn't going to happen. I mean, I did an experiment on my sons and their friends saying, I know you're all interested in trying to stabilize the climate. Would you be prepared to have your standard of living lowered by a factor of 3 times in order to stabilize the climate? They said, well, we'd rather see the end of human civilization than do that. So, I mean, they've been raised in a Christian home. We've been providing for them economically, but it shows you that people, even with the advantages, aren't going to buy into this. So, and then a second principle is being overlooked is the command that we get in the book of Genesis and the book of Job, is that God has given us human beings a command. We're to manage the planet and its resources for our benefit and the benefit of all life that shares this planet with us. That implies that we will not have to make a choice between managing the planet's resources for our benefit or for the benefit of all non-human life. We're going to be able to do both. So I got 2 chapters in the book basically making the point there are things we can do to extend climate stability for at least 1,000 years, and at the same time boost the world economy, and in particular, boost it for the poorest people of the planet. And it's going to be beneficial for the ecosystems. Everybody wins. The plants and the animals on the planet benefit. We humans benefit. The climate is stabilized. Who's going to vote against us? One of my motivations for writing the book was to take the politics out of the global warming debate. Look for these win-win solutions. The Bible tells us we'll find them if we look for them. I'm going to give you quick 3 examples. There are 40 in the book, but I'll give you just a quick 3. And one of them is we can restore the Sahara Desert back to where it was in the days of the Roman Empire. Today, the Sahara Desert is bigger than Australia, but it wasn't always like that. Here shows you a map of the Sahara Desert. But in the times of the Roman Empire, the Sahara Desert was just 1/10 of what you see right here. In fact, what we now call the Sahara Desert was the granary for Europe. Rome fed all of Europe with the grain that was produced in what is now the Sahara Desert. What has caused it to be as large as it is that people living on the south edge of the Sahara Desert have been stripping the land of vegetation and using it for cooking fuel. And it's slowed down a little bit, but if you were to go back 30 years, the Sahara Desert was advancing south at a rate of 10 kilometers per year and was in danger of going all the way down into and covering all of Nigeria. I mean, 100 million people live in Nigeria. If it wasn't for the fact that we slowed down the advance of the Sahara Desert, Nigeria would be 100% dry. Now, one of the proposals I put in the book is that we can actually share with the South Saharan populations and say, we're going to give you, I know you want cooking fuel, we're going to give you all the kerosene you want free of charge. Use it as generously as you want on one condition, that you work with us to replant the Sahara Desert. And it literally can be done in 20 or 30 years. We can reverse the Sahara Desert, bring it back to where it was at the time of the Roman Empire. We can now plant the Sahara Desert with grains. This would provide an income for the people who live there. It would soak up huge quantities of greenhouse gases. It would restore the ecosystem. So instead of just a few desert rats running around, we can now have a diverse ecosystem thriving in this desert. And we can do the same thing for the Gobi Desert. The Gobi Desert is 4 times bigger today than it was 2,000 years ago. And actually, I think there's better hope of getting that reversed because the Gobi Desert in the last few years has penetrated the suburbs of Beijing. So Beijing is being threatened with being turned into a desert. But it could be reversed as well and turned into an income supply. Okay, a second example is that we can actually use the crisis in the Amazon to benefit the whole world and help stabilize the climate. So this photo here shows you the Amazon jungle. And you're probably aware that people living in the Amazon have been going through the jungle and basically burning huge swaths of the jungle, not even selling the wood, just burning it and converting into pasture lands because they think they can make money off of beef cattle. They're not aware that Amazon soil is not rich enough to be turned into pasture land. Yes, you can have beef cattle industry for about a 5 or 6 year period, but after that you denude the soil of nutrients, and now you've got a desert on your hand instead of a jungle. I mean, 50% of the rain that falls in the Amazon is from the transpiration that takes place from the trees that are there. Take away the trees, you quickly turn that region into a desert. And if we actually look at the Amazon figures, it's 5.5 million square kilometers. It's more than half of the Earth's rainforest. But if you were to take deforestation to a level not really far beyond where we are right now, the forest no longer produces the rainfall to sustain itself, and you wind up turning the Amazon basin from one of the wettest spots on Earth, literally, into a dry desert. And this shows you the degree of deforestation that's taken place. 1970, the Brazilian Amazon encompassed more than 4 million square kilometers. Today, it's dropped below 3,300,000. A 20% loss has occurred. And so what I've written in the book is we can educate the Amazonian peoples that they're going to lose money if they try to convert this jungle into pasture land. Certainly over the long term, they're going to lose a whole lot of money. They'll make a lot more money if they leave the jungle alone on one condition. They need to go through the jungle and harvest out the old trees. The big old trees are where you're going to make the most money in terms of lumber. And so you're going to be able to sell the lumber and that's going to be converted into furniture and homes, where the carbon there gets sequestered long term. And these old trees don't grow as fast as the young trees. Moreover, it's the old trees that are in the greatest danger of dying. And when they die, they release carbon dioxide to the atmosphere. So if we really want to take care of the Amazon, we'll go through it, harvest out the old trees that are in danger of dying, sell that for lumber, and replace those old trees with young trees. And research now shows that these younger trees pull carbon out of the atmosphere at 4 times the rate that the old trees do. So we could actually make the Amazon far more productive in actually building up lumber, but far more productive in pulling out greenhouse gases from the atmosphere. And incidentally, this applies worldwide. This is a rainforest where I grew up in coastal British Columbia. And you can see the problem here. They just let the old trees die. The old trees fall down, they rot, and they release greenhouse gases to the atmosphere. We'd be far better off to harvest those trees and replant them with younger trees. And incidentally, when you do that, wildlife now has access. When you have all these dying trees in the forest, it limits the capacity of these animals to move through the forest, particularly because the dying trees actually provide a basis for the Himalayan blackberry, which basically makes these forests impenetrable. And so this would be a good thing for the wildlife there. And have you ever been to some of the national parks in North America? You notice a lot of them are filled with dying trees, mainly because they've let the trees get too populous. And the bark beetles get in there and kill the trees. And the tourists don't like a national forest or a national park filled with dead trees. So you're far better off in the wintertime harvesting the older trees and actually making the forest beautiful again and making it productive for wildlife. And then the last thing I want to share with you is we've been overlooking a source of energy that could be, it would literally free us from fossil fuel dependence for energy. And this shows you a thorium reactor on the Hudson River back in the 1960s. And some of the things we've noticed with thorium is it's 3 times as abundant as uranium and delivers way more energy than uranium does. 1 ton of thorium delivers the energy equivalent of 200 tons of uranium or 3,500,000 tons of coal. The United States has enough thorium to produce 100% of its total power needs for at least the next 1,000 years. India's got the largest store of thorium in the world. Australia's got a huge store of thorium. And thorium is very easy to mine. 1,000 times less radioactive waste. The waste is actually safe to touch after 200 years. And with proper protective clothing, you can actually handle it even after 50 years. What's the problem with uranium? It's not safe to touch even after 50,000 years. And also you need special protection to mine the uranium. That's not necessary for thorium. No need to wear protective gear to mine the thorium. And some other advantages, much safer and more efficient to mine than uranium. You can open pit mine it, so it's very cheap to mine. Thorium reactors are meltdown proof. Not the case with any uranium reactor, but it's simply impossible to have a meltdown with thorium reactors. You say, well, why didn't we go for this back in the 1960s? The reason why is thorium nuclear power plants cannot be used to make nuclear weapons. So that's why the United States and Britain and other nations, Russia, basically abandoned thorium reactors. We can't make bombs out of it, so forget it. But today that's considered an advantage. That means that we could actually provide thorium power reactors to all the nations of the world without any concern that they're going to use these thorium power reactors to make weapons. It can't be done. And incidentally, there's no risk to the people who work in these power plants. And it would take a decade of construction, only 1 decade, to provide 100% of the world's power needs. And you say, well, how expensive would this be? It would actually be cheaper than water power in Canada. I mean, you've probably heard of these electric cars. Where we live in Southern California, they're not an economic option because electricity has got to come from the burning of natural gas. But in Canada, for example, they're able to drive their Teslas, their 5-passenger Teslas, for 500 miles, 800 kilometers, for the price of 50 cents. That's because of how cheap electricity is, because of the fact that they get their electricity from all the waterfalls that exist there in Canada. But thorium would actually be cheaper than water power. It would literally be the cheapest source of power of any option we would have there. Would basically motivate people to use fossil fuels to make plastics and for chemical industry and not use it for fuel. Anyway, you can read more in Improbable Planet and also in Weathering Climate Change. Again, you can get a free chapter at reasons.org/Ross. With that, I'll exit and we'll take you back to our gallery here, and I'll take questions on any subject that doesn't have to be necessarily on climate change. So whatever you want to talk about.
Thank you very much. Can you unmute your microphones if you'd like to talk? But Hugh, can you see the chat?
I'll open up the chat because yeah, I see 27.
Yeah, so would you actually like to walk through some of those comments and questions?
Okay. Thorium reactors still produce heat? Yes, they do. And can you divert the heat for human use? Definitely. That's how you get the energy out of them. Use the heat coming from the thorium reactor to drive a steam turbine or some of the more sophisticated turbines that are recently being developed. And let me see if I can, let me go to the top. I was at the bottom.
Yeah.
Where can I get the book? You can get it at reasons.org. We will ship it to Australia. I know it's available on Amazon in the US and in Canada. I think it's now being picked up at Amazon UK. I don't know whether you can get it at Amazon in Australia.
You can.
You lag behind. You can get it?
Yes, I downloaded it with Kindle, so it's really easy.
Oh yeah, Kindle is easy. You can get that anywhere, but if you want the hard copy, I'm not sure whether you can get that yet. But I know you got a big bookstore there in Australia. I've been to Australia 3 times, and I'm trying to remember Kurong or Kuru or something like that.
Kurong.
Yeah.
Kurong. Yeah.
If we could persuade them to carry the book, we had reasons to believe we'll ship them cases at very deep discounts. And so maybe one of you could actually approach them and see if we can get them to carry the book.
Yeah.
But if you want to order from us, we'll get it to you. In fact, I would say as far as your little chapter here goes, the most economic way, place a bulk order, and we'll ship you all the books in a box, because that way the shipping is much cheaper if we ship them all in one box rather than individually. And also, if you order, say, a case, we can give you a really good discount. So that's something you can do privately through Reasons to Believe. Would we find a crater? Oh, somebody was asking a question that said,
would we find a crater for the asteroid impact you talked about that were in the sea?
The one off the tip of South America, there is no crater because it dropped into 17,000 feet of water, 5,000 meters of water. And so the water basically absorbed the energy. However, it did penetrate all the way to the seafloor, because as they scour the seafloor, they find all kinds of rocks and pebbles
So is
that
it
have,
still sitting there?
yeah, it's still there. And so they find the remains of the asteroid, and they can tell it's from the asteroid because of the isotope signatures. Yeah, over what I describe in the book is over about a 300 by 500 kilometer area. It's filled with all of this debris from the asteroid. But basically what happened is the asteroid hit the ocean with such force that it broke apart the asteroid into all kinds of tiny pieces and actually launched a tidal wave 300 meters high.
Okay. I'm just gonna ask Mom if I can have another piece of toast.
Okay, here's one. How does an astrophysicist learn all this? What we've done at Reasons to Believe, when I was on the faculty at Caltech, it was such a competitive environment. I only had time to read the scientific literature that was relevant to my very narrow subdiscipline. And so what we're doing at Reasons to Believe is we're taking top academics out of the academic arena and setting them free to do interdisciplinary research. And it wasn't until I left Caltech that I actually had the luxury of being able to read the scientific literature in areas outside of my narrow subdiscipline. And incidentally, we get a lot of kudos from the scientific community. They appreciate the fact that we are taking the time to do this interdisciplinary work. And I get, in fact, I was speaking to a group of astrophysicists at Durham University 2 nights ago, and they just told me how much they appreciated that we actually read across the astronomical literature. None of them have time to do that. They just look at their own narrow subdiscipline. And also explains why so many scientists say, we see no evidence for God. They're only looking in one subdiscipline. If they actually were to look at multiple disciplines, they would see it everywhere. And there's also another important caveat. If you're a life scientist doing your research in the human era, that's God's 7th day when he's resting from his work of creation. And so in the human era, the scientists will only see evidence for natural processes, not supernatural. God's resting from his supernatural work in creation during the human era. But explains why so many astronomers do believe in God, because their data comes from the past. Because of the velocity of light, their observations are coming from deep time, and they see the handiwork of God everywhere. Okay. Yeah, the last cycle is rather chaotic. Actually, all the cycles are chaotic, except for the one, the warm interglacial we're in right now.
The last one is more chaotic.
Well, the reason why is I show it to you at full resolution. The previous slide, I wasn't giving you the full resolution. So that slide where I showed you the 80,000 year window, that was full temperature resolution. But that's typical of the entire previous 2.5 million years, both for the glacials and the interglacials. So what you see there is characteristic. Okay, moving on down. Why at minus 30 degrees in a stable period? That's because I was using the actual temperatures at the site of the deep ice cores. That wasn't the global mean temperature. That was a temperature at that site. And the reason why I chose that rather than converting to the global mean is that you actually get more accurate temperatures if you do it relative to the core sites. And what I didn't share with you is that's now been confirmed with deep ice cores in not only at 5 sites in central Greenland and northern Greenland, but also at 6 sites in Antarctica, central Antarctica, in the Alps, as well as in Canada and the Andes and the Himalayas. That's the most recent one. So it's basically showing you this isn't just the polar extremes, It literally is all over the globe.
The what do you mean is referring to Grandad's question that you just talked.
Okay, what was that question?
The one he just said in the chat before I wrote, what do you mean?
Why minus 30 degrees? Or the one before that, where he says there might be many things, ice cores, rock data, predictions based on data. Yeah, I wasn't sure what that was all about, so that's why I skipped it. But whoever posted that can tell me the context.
That
I'll
was
do
in
my
response
best.
to him.
That was in response to you, Kevin.
Oh, it was a response. Okay, so I can skip that?
Yeah.
Okay. The stability started around the same time as the first agricultural revolution. That is correct. What happened is that with that asteroid colliding in northwest Greenland, within a few decades, it brought about a brief period of climate stability, which humans took advantage of literally around the world to scale up their agricultural activity, to begin building towns, and they began to specialize, where one group of people would only grow wheat, another group of people would only raise goats, another group would simply manufacture pottery products, and they began to trade with one another. It's referred to as the Neolithic Revolution, which got launched about 10,500 years ago. And with the launch of that agricultural revolution, that's when human activity began to counterbalance the natural cooling. The tilt of our rotation axis, the change of the shape of Earth's orbit, began to dramatically cool the planet. Normally, that would have quickly dropped the temperature globally by 10 to 12 degrees centigrade. That didn't happen because when humans launched agriculture, they domesticated cows. The cow population went up. The cows, when they're domesticated, greatly increase the carbon dioxide emission from those cows. We domesticated rice and figured out that if we flood the rice fields, we can stop the vermin from attacking the rice, so we get more productivity. But that also greatly increased the release of methane to the atmosphere. And so the release of carbon dioxide and methane as a result of human activity with the launch of the Neolithic Revolution perfectly counterbalance the cooling that came from the changes in Earth's orbit and the tilt of Earth's rotation axis.
It
That's
also
literally
increased our need
continued
for
to this
water.
day. Pardon me?
The rise also increased our need for water.
Increased what? Wasn't quite getting that.
Our need for water.
Oh, a need for water. Well, the last ice age was the most drastic of all the ice ages. And so, for example, during the last ice age, 55% of North America was covered with thousands of feet of ice. And the Himalayan plateau has been rising. You'll see a chapter on that in the book, that we had the Indian subcontinent collide with Asia, and that brought about the Himalayas and the Tibetan Plateau. That collision is still going on to this day. So it explains why the Himalaya mountains are getting taller every year and the Tibetan Plateau is rising. It also explains why every ice age gets more severe than the previous ice age. And not very many people realize, but there's actually more store of ice in the Himalayas and the Tibetan Plateau than there is in the Arctic ice cap. The third largest store of ice on planet Earth is in the Himalayas and the Tibetan Plateau. And it actually has a significant cooling effect, a bigger cooling effect than what happens in Antarctica. Even though you got much bigger area covered with ice, the Tibetan Plateau, because it's so close to the equator, reflects sunlight 4 times more efficiently than ice in Greenland and ice in Antarctica. And so having India collide with Asia has been the second biggest factor explaining why we've got ice in spite of the fact that the sun is brighter than it's ever been before in the history of life on planet Earth. And today, even today, that ranks as the fastest tectonic movement on the Earth. Before the collision, we had India moving northward at 22 centimeters per year. It's now moving northward at 5 centimeters per year. But it's such that the Tibetan Plateau is continuing to rise. I mean, to give you an example, we now know that Sir Edmund Hillary did not climb the world's highest mountain. Mount Everest was more than 1.5 feet lower than it is today because of that ongoing collision. So if you climb Mount Everest next year, you will be climbing the world's highest mountain.
That's amazing.
How was the crater covered up? Well, that's a very cold area of the world, and yes, so the asteroid in northwest Greenland penetrated through 3,000 feet of ice, but within a few thousand years, that ice got restored and covered up the crater. And how was it that the lakes got to be so big? Well, you have 55% of North America covered with 3,000 feet plus thickness of ice. That ice melted over a period of just a couple of thousand years. And so that explains why you had this gigantic glacial lake, Lake Agassiz. Also explains all the incredible canyons that you see in North America. Yosemite Valley was carved out with a retreat of ice from the last ice age. And you see canyons like that all over North America, where you got sheer vertical walls that rise 4,000 feet high. In fact, I visited one in southern British Columbia. It's a 1/2 mile wide canyon, vertical granite walls more than 2,000 feet high, with 25 waterfalls that spill over the canyon walls from the melting of glaciers that still exists there above the canyon. Scenery like that exists all over North America and to a lesser degree in Northern Europe. In fact, I make a point in this book that we humans are actually living at the scenically most beautiful time in the history of planet Earth. I mean, Tasmania, for example, likewise had beautiful scenery that's carved out by the retreat of ice from the last ice age. The great harbors of the world were carved out by the retreat of ice from the last ice age. New York Harbor, for example, Vancouver Harbor were all carved out by ice that was retreating 13,000 years ago.
Darwin Harbour?
No.
Darwin.
Although
What? It's a big harbour.
there is some evidence that Sydney Harbor also benefited from the retreat. It wasn't that so much that ice got carved out in Sydney, but there were ocean current movements and rainfall movements that played a role in making Sydney as beautiful as it is today. Okay, what is actually measured in the ice cores that enable us to get the temperature? What they do is they look at air bubbles inside the annual layers of the ice, and they measure the ratio of oxygen 18 to oxygen 17 to oxygen 16. And that gives you a very reliable measure of the temperature of that ice at the time that ice layer was laid down. So we can literally get an accurate temperature measurement on an annual scale, literally every year, going back now 800,000 years. And there's research going on where they hope to extend that back to 1.5 million years. They've now found another site in Antarctica where they can go back that far. Off of New Zealand, they have sediment cores that reveal the global mean temperature, not on an annual resolution, but on a resolution of a few decades that takes you back 4 million years. Can you talk about the supernova significance? Yeah, I got a chapter on that in the book, making the point that we know this is the hand of God and not just some lucky circumstance, because we have the sun entering extremely stable luminosity phase about 50,000 years ago. And we know that's only going to last for about another 50,000 years. We enter this period of extreme climate stability 9,500 years ago. And also 9,500 years ago is when we entered this window where there's no nearby supernova eruptions. If you go into the last ice age, astronomers have used isotope measurements to confirm that there were 23 nearby supernova eruptions during the last ice age. In fact, I think there were 8 that took place between 10,000 years ago and 44,000 years ago. And that's the norm for our Milky Way galaxy, that we would expect supernova eruptions that are closer than 900 light years to occur in that time scale. Now, that doesn't mean you get the end of human beings. If you've got supernova exploding, say within 200 light years to 900 light years, that does increase the cancer rate. That does mean that we humans won't be as healthy as we are today. But the bigger effect is it affects plant productivity. And so plant productivity drops way down when you have those supernova eruptions. What I point out in this book is over the last 9,500 years, the nearest supernova was 5,000 light years away. So far away, it has zero effect on human health or human lifespan, and has zero effect on plant productivity. But that's never happened before in the history of the galaxy, where we got a 10,000 year window where there's simply no nearby supernova within a 5,000 year period. And something I'm writing in a book I'm working on right now, it didn't make it into Weathering Climate Change, but as we look at galaxies around us, we see that all the nearby galaxies currently have their central supermassive black hole in a very quiet phase. And our Milky Way galaxy, of all the large spiral galaxies, has got by far the smallest supermassive black hole. Our black hole is about 100 times smaller than we see in the Andromeda galaxy. And as small as it is, it's also in the quietest phase it's been for thousands of years. And when we look at the Andromeda galaxy, normally its supermassive black hole would be a problem for global civilization. But for the last 10,000 years, the supermassive black hole in the Andromeda galaxy has been in a quiet phase. That's actually true of all the galaxies in the local group. It's true of the galaxies in the Virgo cluster. The really dangerous one is the one that's in M87, 50 million light years away. But right now, its supermassive black hole is pointed away from us. So yes, it's pouring out deadly radiation, but for the last 10,000 years, it's been pointed away from our galaxy instead of towards it. So the bottom line is, there's actually a lot of narrow time windows that are simultaneously overlapping. I've counted over 15 such narrow time windows. And so the fact that they all are simultaneously overlapping, I'm arguing, is evidence for the supernatural handiwork of God, because there's nothing in the natural physics that would expect them to overlap. They're all independent of one another. And yet now they're all overlapping, and they have to overlap if we're going to have billions of human beings that can hear the gospel message and receive it and be redeemed so that they can enter into the new creation.
Oh, there was mention of the moon there in that spot.
Right now I'm down to the fossil record. So I'll answer that question, then I'll try to find the moon question. The significance of the fossil record is what you see in Psalm 104, verses 29 and 30. It's a property of all life to die off, but God recreates and renews the face of the earth. And I began by showing you that slide of how the sun gets brighter and brighter. as the sun continues to fuse hydrogen into helium. And life on planet Earth can only tolerate about a 1% change in the brightness of the sun. How God's been able to deal with that is by regularly removing most of Earth's life from planet Earth and replacing it with new life that's more efficient on pulling greenhouse gases out of the atmosphere. So as the sun gets brighter and brighter, God, through mass extinction events and mass speciation events, ensures that we got just the right life on planet Earth at just the right time to make sure that greenhouse gases are being pulled from the atmosphere at a rate that perfectly compensates for the brightening of the sun. And when we astronomers look at the brightening of the sun, we've calculated that you need an intervention event like that about once every 30 to 35 million years. When you look at the fossil record, that's exactly what you see. Mass extinction events occur about every 30 to 35 million years, quickly followed by mass speciation events. And my point is, only a mind that knows the future physics of the sun would know which life to remove from the Earth and what new life to replace that life with. If you're counting on naturalistic processes, it doesn't have that knowledge and therefore will quickly get out of sync and our planet becomes permanently sterile. What role do you see Neanderthals and other such life having in the history of life on Earth? Do they show any evolutionary change? Do you believe humans evolved from these creatures? Well, this is where conservation biology has a factor. And I would wish that evolutionary biologists would read that biological literature because it's relevant. What we see in conservation biology is that any mammal species that's got an adult body size larger than 3 kilograms goes extinct before it can evolve into a different species. And we look at the Neanderthals. In fact, when we look at all the bipedal primates, they all have adult body sizes a lot bigger than 3 kilograms. And we actually look at the bones of, say, the Neanderthals. Neanderthals were here on planet Earth for a 200,000 year period. But the oldest skeletons are identical to the most recent. We see no evidence for any change in the skeletal structure of the Neanderthals. And we've been able to recover DNA from 22 Neanderthal specimens. Likewise, we can't see any change in the DNA. So that's additional evidence that they're not experiencing evolution. And we compare Neanderthal DNA to human DNA. When we compare Neanderthal skeletons to human skeletons, we see that they're dramatically different species. Neanderthal basically had the morphology to deal with a cold climate. Barrel-chested, short limbs, huge nasal capacity, and but humans quickly replaced them in climate zones that were 15 degrees colder than what Neanderthals could tolerate. The reason why? Humans had a body that was beautifully designed for a hot climate. We're slim, we're tall, we got a great perspiration system, we got long limbs, we got very little body hair, so we can handle heat. However, we can't handle cold. But because humans had a large parietal lobe in their brain, they were able to quickly launch clothing technology. And it's the fact that humans wore clothes and Neanderthals did not, that we quickly replaced them. And I've written in my book, Navigating Genesis, that research in Australia, North America, and South America shows why the God of the Bible would create 10 to 12 different species of bipedal primates. Because what they've noticed is that when humans came into Australia, they drove to extinction 94% of the large-bodied bird and mammal species that existed there. And consequently, the Aborigines were not able to launch civilization. They wiped out all the animals they needed to make that happen. Whereas the extinction rate in sub-Sahara Africa, by comparison, was just 4.5%. Here's the difference. Sub-Sahara Africa had 10 distinct species of bipedal primates over a 6 million year period. Australia had none. We found no evidence for bipedal primates previous to humans in Australia. And so what we're arguing at Reasons to Believe is that when you look at these bipedal primates, we see there's chaos with respect to their brain capacity. There's chaos with respect to their bipedal capability. It literally goes up and down like this as you look over the 6 million years. The only thing that's linear is we see an increasing capability to hunt large-bodied bird and mammal species. And what you see in the book of Job is that God designed birds and mammals to relate to us human beings and to serve and please us. It was God's intent that we would tame them and be able to use them to launch civilization and be able to bring them into our homes as household companions. And these animals are, God endowed them with a capacity to seek out humans. However, once we sinned, we became a risk to those animals. And we see that in Australia and North and South America. North America, for example, humans came over the Bering Land Bridge during the last ice age and quickly wiped out the mastodons. I mean, it's an easy meal. You hunt one mastodon, you can feed your tribe for a whole month. And so it was an easy life, but they wound up wiping out the mastodons. They wiped out the horses. They wiped out the sheep, all the animals they needed. They wiped out donkeys, camels. Those all existed in North America and Australia, but they got wiped out. The very animals we most needed to launch agriculture and industry. But what happened in Asia and Europe and Africa is because of the exposure to these bipedal primates, these animals were over a period of time trained. When you see tall bipedals with weapons in their hands, run. And so these creatures escaped human predation in Africa and in Europe and Asia. They did not in North and South America and in Australia. And explains why the people living there were not able to launch civilization or develop a large population until Europeans brought the animals that they needed. Okay, let's see if I can find this moon question.
10:40.
Or 10:40 a.m. our time. I don't know what time the people
Yeah. It says it's from Bronwyn.
Yeah.
So can you talk about the supernova significance in mass history?
It's supposed to be.
What role the moon plays in climate stability?
The supernova with respect to what about the moon?
Oh, it's just, it's the second part of that question. You answered the supernova one, Hugh, but what role does the moon play in climate stability?
Well, the moon plays a role in that it stabilizes the tilt of our rotation axis. I made the point that because of the tidal forces of the moon, our rotation axis varies over a 41,000 year period from 24.5 degrees to 22.1 degrees. And when it goes over to 24.5, we warm up. Right now, it's going towards 22.1, so it's actually cooling our planet. But because it's only a 2.5 degree change, the degree of cooling and warming is reasonably small. Not the case with Mars. Mars, the rotation axis tilts back and forth by 60 degrees. It explains why the polar caps on Mars are as small as they are. Earth, Venus, and Mars all get bombarded by comets. The moon gets bombarded by comets. If you go to the south pole of the moon, there's an ice cap there. That ice cap formed because of comets colliding. Comets are 85% frozen water. And so if that comet lands inside a lunar crater where the sun doesn't shine, that ice is going to be permanent. Well, that also explains the fact that Mars, as water poor as it is, has a polar cap. because comets bring frozen water. It forms a polar cap, but notice how small the polar cap is. What happens is that the rotation axis of Mars tilts over by about 60 degrees, which exposes the polar cap to warmer rays from the sun, melts the cap, and the cap disappears to outer space, but a new cap forms because of comets bringing in additional ice load. And if that were to happen here on planet Earth, it would simply be impossible for human civilization on our planet. If the rotation axis were to tilt over that far, the climate extremes would be so great that we couldn't have a large population. In fact, it'd even be doubtful if humans could survive at all on our planet. And, you know, it's thanks to a small rocky planet being orbited closely by a gigantic moon that we have a stable rotation axis tilt. No other planet in the solar system has that. And astronomers believe this may be the only system in an entire galaxy where you got a small rocky planet orbited by a large nearby moon. And in fact, we now know how the moon formed. It didn't form like other moons. It formed as a result of two large planets colliding with one another, actually merging with one another. They have a name for this planet, Theia, more than twice the size of Mars, and collided with the Earth when the Earth was 95 million years old. And that made our planet bigger, made our planet super endowed with uranium and thorium, which made possible for us to have a strong magnetic field and plate tectonic activity. If it wasn't for that collision event, we wouldn't have either, and we wouldn't be here. But it also led to the formation of the moon. And I wrote in Improbable Planet about the fact that people who studied the origin of the moon said, wow, we're looking at all this, and there's way too much fine-tuning design here. We need to redo all of our lunar formation models and see if we can lower the level of fine-tuning that we're seeing in the moon. They redid their models, but the level of fine-tuning design went up instead of down, and went dramatically up. And I actually quote one of the researchers. This is in Nature, which is interesting because Nature is managed by a team of atheist scientists. But they allowed this quote to go in, basically saying, now that we've redone all these lunar models, it's imposing upon all of us philosophical disquiet, implying that, hey, something supernatural must be going on here in order to explain this massive amount of fine-tuning we see in the moon. So there's actually books that have been written about what would happen if the moon didn't exist. But the bottom line is over 30 different features of the moon have to be fine-tuned to make global human civilization possible. The tides, for example, are a critical factor in explaining why we have such an abundance of food coming from the oceans. Okay, I got a question here about Noah's Ark. In your book, Navigating Genesis, you refer to an observation made by an evolutionary biologist in regard to animal life came out of Noah's Ark and the speciation arising from this. Can you elaborate on this for us? I covered this in my book, Navigating Genesis, and again, you can get a free chapter at reasons.org/Ross. But I make the point that if you examine all the texts in Genesis 7 and 8, you see that the animals that went on board the ark were the basar creatures. And that's referring to animals that are the soulish animals, the birds and mammals that are in relationship with human beings. Those are the animals that God commanded Noah to take on board the ark. And so we're not talking about him taking on a whole bunch of amphibians. It's basically these bird and mammal species that are in relationship with Noah and his family. And likewise, the animals that are destroyed by the flood, it's all the humans that were not on board the ark, plus all the soulish animals that are in relationship with those creatures. meaning that there was no need for Noah to take on board the ark polar bears or kangaroos or penguins, because none of those creatures would have had any contact with human beings, and therefore they wouldn't have been damaged by human sin. It's a principle you see in the book of Leviticus, that the only animals that can be negatively impacted by human sin are the soulish animals that are in relationship with sinners. I refer to it as the mean dog syndrome. Mean dogs are owned by mean human beings. So if you ever run into a mean dog, watch out for the owner. And you actually see this in the book of Leviticus. It says, for example, if a cow is in the habit of goring other animals or goring human beings, then the owner of that cow is to be spoken to. And if the cow persists in that behavior, the cow is to be killed and the owner is to be killed along with the cow. Making the point that the only reason why the cow is behaving that way is because of the human owner. I mean, why are dogs mean? Because their owners really encourage the dog in that mean behavior. If any of you have ever owned a dog is highly motivated to please its human owner. And bringing pleasure to the human owner is for that dog to attack other animals, other people. That's exactly what the dog will do. It's not that the dog is a sinner. The dog is simply trying to make its human owner happy. But that's the reason why God said these animals have to go. They've been damaged by the reprobate behavior of their human owners. And you actually see that too in the books of the Judges and 1st and 2nd Samuel, and Joshua, that there were times when God said, hey, when you conquer the city, you got to kill all the animals. They're damaged beyond repair because of the wickedness of the people that live there. Now, as far as the evolutionary biologist is concerned, if we're talking just the bizarre animals, then there is no response. I mean, what evolutionary biologists are doing is critiquing the young Earth model, where they claim the flood is global and wiped out all land animals. And they're basically saying it's impossible for the few thousand species on board the ark to be able to evolve into the millions of species that exist on Earth today. Matter of fact, I got some books by atheists here behind me who basically make the point that the most aggressive evolutionists on the planet are young Earth creationists. That to support their young Earth model, they have to invoke naturalistic biological evolution at a rate 100,000 times greater than what any atheist would dare to propose. And that's an accurate statement. I would agree with that, that because of their flood model, they're stuck in that position. They're stuck for another reason, because they believe that there are no carnivores until after the fall of Adam. So they have to have all these herbivores rapidly evolve into carnivores in a very short period of time. And again, the atheists have pointed that out, that that is simply not possible. Okay. How unique is our sun? Well, I'm writing a book right now. It's tentatively titled Interior Designs. It's got nothing to do with furniture, but it's all about the interior design of our super galaxy cluster, our galaxy group, our solar system, our star, our Earth, our moon, etc. And when you look at the interior of the sun, it really does reveal that there is no star like the sun. Matter of fact, I know astronomers who've spent 60 years trying to find a twin of the sun, a star sufficiently like the sun that it could be a candidate to have a planet orbit. And over 60 years, they have found many stars that are twins of one another, but they've yet to find a star that's sufficiently like the sun to be a candidate. Matter of fact, I think there's, I think it already came out. I wrote an article at reasons.org showing the luminosity stability of the sun relative to the most stable stars we've been able to find in our galaxy. and basically shows you that the luminosity stability of the sun is at least 5 times superior to the best other star we can find in our Milky Way galaxy. And we look at the interior physics of our sun, we begin to discover the reasons why. You can actually blame it all on Saturn and Jupiter. There are gas giant planets that migrated towards the sun, stopped and reversed and migrated away. Of all the extraplanetary systems we've seen, the vast majority of their gas giant planets go inward and stop, or they don't migrate at all, or they migrate outward. Unique to the solar system are its 2 biggest gas giant planets migrated inward, stopped well short of where the other planets migrate, and reversed and migrated back outward. And what that did is it caused all the small planets orbiting close to our star, the sun, to be sucked into the sun. And that actually changed the chemistry of the sun and explains why our sun is so different than all other stars. That's only one reason why it's different. There's actually multiple reasons. Its magnetic field is different than any other star. Anyway, you'll have to wait about 1.5 years before that book comes out. Let's see, I think I've answered all the questions.
Okay, then we'll open it up for any verbal questions or comments.
And Hugh, I'd like to refer to the ice cores that we talked about. I put that question to you earlier. How do you know that those different measurements are annual measurements in the ice cores? I appreciate that they're seeing a variation as through the ice cores, which obviously must relate to time of when that ice was formed. But how do you know it's annual?
Okay, there's several reasons why we know it's annual. Number one, we can see the cycle of the tilt-averse rotation axis in the Ice Age cores. We can see that 41,000 year period being manifested. We can also see the 100,000 year period of the change in the ellipticity of the Earth's orbit. So we can look at the Newtonian physics of our solar system and compare it with the ice core record, and they match. Another reason why we know they're annual is that we can see the volcanic dust signature of volcanic eruptions that took place in recorded history. So Krakatoa shows up there, for example. All of Vesuvius eruptions show up there. In fact, all the volcanic eruptions over the past 8,000 years show up in the ice core records. And then you can count the layers in between, and they tell us that they're annual layers.
Okay.
Third reason we know is we can actually see carbon-14 signatures in the ice core layers. And that can be related to the layers that we see in tree rings. And that's just a few of the reasons why we know they must be annual layers. Now that works if you're talking certain ice cores. They did an ice core in southern Greenland, and they're not annual layers because it's so warm in southern Greenland that you actually get melting taking place in the winter and refreezing. So you actually get multiple layers per year. And that'd be true in certain parts of the Alps. And so what these geophysicists have to do is go to places on the planet where we know no winter melting has ever occurred. So you want to go to exceptionally high altitude or extreme northern or southern latitude places. That's one reason why they don't do the core drills on the coast of Antarctica. They go 1,000 miles into the interior. They go to high altitude, like 12,000 feet. And there they can be assured there's no way that winter ice is going to melt.
Okay. Thank you. All right, well, I've got another one. A while ago, I read about a project or a venture that was to do with seeding the oceans, the way out from continents, with iron salts. And it had a dramatic effect on improving the life in the oceans. It was discontinued for some reason or other. I think it was political, really. But it actually showed it had a phenomenal effect on life in the ocean. Do you comment, or have you any comment about that? Do you know of that?
Yeah, it's in the book, Weathering Climate Change. I also explain the reason why it was discontinued. The reason why it was discontinued is it actually caused these toxic algae blooms to generate, which was actually poisoning the fish in the oceans in that region. So they basically said, well, yes, it does pull more greenhouse gases of the atmosphere, but if you kill all the fish, they rot, and that puts greenhouse gases in the atmosphere. It also means we got less fish to harvest. So they said, we're not going to do this anymore. So there's been a worldwide ban on doing that iron fertilization.
Right.
On the other hand, what I comment in the book is that we do know that the iron fertilization from whales doesn't have the same consequences. And that's actually a research that came out of Australia. There was several Australian oceanographers that began following these pods of sperm whales and noticed that where you had got sperm whales, you actually have a large fish population. And that's because these sperm whales feed on giant squid, thousands of feet below the ocean surface. And these giant squid are very rich in iron.
Mm-hmm.
And these sperm whales are biologically designed that they only defecate on the surface. And unlike other creatures in the ocean, they defecate soluble iron of just the right composition that fertilizes the phytoplankton without generating these toxic algae blooms. And so I make the point that, you know, it'd be really good if we were to bring the whale populations back. By the way, the whales that feed on krill, same thing. So bringing back the whale populations to where they were 300 years ago would not only stabilize the climate, help stabilize the climate, it would greatly increase the fish stocks. And what these Australians discovered, which was pretty enigmatic, the only creature that feeds on these giant squid are sperm whales. But when they brought the sperm whale population back, the squid got more numerous and got larger. They said, hey, we brought back their predator. How come there's more of them? And how come they're bigger? Well, what happened is the whales actually increased their food supply by fertilizing the phytoplankton. That gave food for the zooplankton, which gave food for the fish, which gave food for the giant squid. It's another example where everybody wins. Oh, I see you had your hand up. What's your question? Eliza, pardon me.
It's just, I'm thinking about the stuff with that. So I'm just trying to think.
Okay, well, I'll let you ask. Think about the question. You got it? Okay.
You know the Noah's Ark thing?
Yes.
Where it said that there are millions of species today and how the few 100,000 wouldn't have been able to evolve in that time?
Yes.
Well, some of those millions of species can be taken out of that amount because aquatic life would have survived on its own.
Yeah, and my point was that God commanded Noah to take on board a pair of every basar creature. So basically he was commanded to take on board the ark a pair of every mammal or bird species that was in relationship with him and his family. So he was probably taking on board the ark a maximum of 1,000 species, maybe less, might have been a few hundred. And there would be no need for evolution because after all the other animals would have been just fine. And my whole point is when you read 2 Peter 2:5, it says the world of the ungodly was flooded. You read 2 Peter 3:6, it says cosmos tote in the Greek. The world that existed at that time was flooded. The point is, in both cases, Peter qualifies the Greek word cosmos. And whenever you've got a qualifying adjective for cosmos, it means part of the world, not the entire planet. In fact, I argue in Navigating Genesis that when you go to the Psalms, Proverbs, and Job, you'll find multiple passages that explicitly state that the flood did not cover the whole world. Probably the most explicit text is Psalm 104, because Psalm 104 reviews the 6 creation days. And when it speaks about creation day 3, when God forms the continents, where he transforms our earth from a water world, where all you got is ocean, to a world where you got oceans and continents. That's verses 6 and 7 and 8. Verse 9 says, once the continents are in place, never again will water cover the whole face of the earth. That's one of 5 passages you see in Psalms, Job, and Proverbs that rule out a global flood. Interestingly, when I've debated young earth creationists on this, their response is, well, Hugh, you're citing the poetic books. The poetic books don't count because poetry can't be used to reveal truth. They're simply ignorant about the Hebrew. Biblical Hebrew is a very powerful tool for communicating didactic truth. And even without knowing Hebrew, you know that must be true because the most explicit teachings on the doctrine of the Trinity are in the poetic texts in the book of Isaiah. And so we should never judge Hebrew poetry by our biases with English poetry. Matter of fact, I would argue English poetry is not that easy for revealing truth either.
When you're talking about rainforest, you're suggesting that we should harvest the dying logs because they actually generated carbon dioxide. But is there actually a danger of interfering with natural processes and that we don't understand the full picture?
Well, there is. You don't want to harvest all the old trees because there are certain creatures in the ecosystem that need these exceptionally tall trees. So what you want to do is leave the healthiest and the youngest of those tall trees alone and harvest the trees that are in danger of dying. Or again, you don't want to harvest them all. Why? Because decaying wood material actually in the capacity of the soil to sustain them to such an extent.
It's glitching out. I can't hear you.
Yeah, the problem with your audio hearing.
Errors to occur.
We can't hear you.
I'll just double check to make sure I don't have.
It's okay now.
Yeah.
Could you just repeat, please, Hugh, from when you said that we shouldn't be taking out all the older trees? We lost you from there.
Oh, he's left.
Oh, okay.
Maybe take them out a bit at a time and wait till the younger ones are strong enough to hold the soil in before taking out any more.
Hey, did anybody get that word that Hugh used, that adjective to describe the animal species that Noah did take on board? I didn't quite catch it. What was he saying?
Star or something?
Could you spell that?
No.
Yeah, I couldn't quite catch that word. It seemed he repeated it several times, so it must be a specific word.
Might need to get him to spell it when he comes back.
Yeah. Okay.
Lost him.
I think we might have lost him.
Yeah.
Guess we'll just bounce ideas back and forth between each other then.
Are you in Antarctica, Eliza?
It's just a virtual background. I thought the glacier represented the topic aptly.
Very good. Very, very nice. How do you do that?
It's in the arrow to the right of stop video.
Okay, yeah.
Choose virtual background, and you'll have to upload an image if you want one other than the preset ones.
No, I actually don't have that. To the right of stop video, there's a big black space, and then it says participants and then chat.
Oh,
So-
we've got choose virtual background.
So if you go to stop video, there should be a little arrow
Oh, yeah, okay. Oh,
Yeah.
press that.
on the arrow.
Oh, how about that? Yeah. Well, thank you very much.
I've got one too. But I'll go back to none, thank you.
I can't do that.
I can change it if you want.
No, no, it's very nice. It's lovely. Better
I
than
mean, I've got lots.
it's better than anybody else's, Eliza.
Yeah.
For example,
Be the Sahara Desert.
I think you've lost him.
boom, boom,
Eh?
boom,
I don't know why.
All right.
boom.
Yeah, all right.
He was not there. He's not coming.
All right. I think we'll probably terminate the meeting now because it looks as though we've got a problem with you.
Yeah, okay.
And I think you gave us a fair bit to think about.
Sure.
Yeah, and I'll follow it up with some emails with reasons to believe and pass on our thanks to him that he bothered to deal with humble little Adelaide. So yeah, so I'm quite grateful for the fact that he took that time.
Yeah.
Yeah, so thank you very much for all your attendance. Is there anybody else would like just to make some general comments before we close?
I'm just thinking about the whole thing with taking out all the trees and creating patches of desert because of cattle. I earlier said just to you, all that for beef? Seriously?
Yeah, well, one of the suggestions he made, I'm not sure whether he commented on it, we should actually start harvesting ostriches rather than than a beef cattle. He did mention it, didn't he? Yeah.
Yeah.
I would have.
Ostriches?
Yeah, ostriches, yeah. Apparently their meat is like filet mignon, and that's a lot better for you, and that they don't do all the farting that cows do. So it's a better option, but that'd be interesting.
He knew for us.
Yeah.
We don't have access to
Okay. I think I might terminate at this point now, so you can all go out and do your shopping. Missed out on that this morning. So thank you all for your attendance, and I'll be in touch with what happens in future.
Hey, Hugh's just come back.
Oh, here he is. Sorry. We had to talk about you behind your back.
about that word you used that we didn't understand.
Bizarre.
Well, we had an internet failure here, so that's why I had to drop out, but I'm back in.
Okay. What was that word, Hugh, that you used to describe the species that Noah took onto the ark? Could you spell that for us, please?
P-A-S-A-R. It's a transliteration of a Hebrew word. And what I do in navigating Genesis is I actually give you the Hebrew word for every animal that's mentioned in the text. There's about 8 different Hebrew words.
Right.
It alleviates the atheist complaint where he says, hey, there's no way Noah could take on a pair of all the animals on the face of the earth. And they're not realizing that if you look at the original Hebrew, it's really a small subset of those animals.
Okay.
And it fits what you see in the book of Leviticus, that it's only the soulish animals, the nephesh animals, that are in relationship with humans that can be damaged by human sin. And so if a polar bear has never had contact with a human being, then human sin has no impact. Therefore, there's no need for God to wipe out the polar bears. He can leave them alone.
Okay.
And we notice too in the book of Genesis that not until chapter 10 do humans become globally distributed. And so we didn't have humans living in Australia. We didn't have humans in North America. They were living in a small locale. They were living during the last ice age. I make the point that the flood must be an ice age event because it took 7.5 months for the water to recede. And for it to take that long, there has to be a huge amount of melting ice. And so I actually will find a map in Navigating Genesis showing the extent of the flood. And it's about 4 times bigger than what you see in other books from an old Earth perspective. So I think people have underestimated the extent of the flood. What was amusing, there was a weekend debate I had with a bunch of global flood proponents. I said, you know, we've come up with a new flood model that reasons to believe, where it's 4 times bigger than your traditional flood model from an old Earth perspective, because we think it's in the last ice age. And if you will make your flood model smaller, we can all meet in the middle and we can be done with this debate. They didn't buy it, but at least I tried.
So you do believe in a historical perspective on Noah's flood?
Well, definitely, I believe it impacted all of humanity, plus all the animals that were associated with humanity, but no way did it cover all of Greenland and Antarctica. And no way did it make the Himalayas. I mean, the big problem with the young Earth model, they got so much plate tectonic activity happening in a 5-month window that it would literally vaporize every life form on the face of the Earth. And would also vaporize all the water. There'd be no water on the face of the Earth if their model indeed was correct. And it also violates the biblical statement that the laws of physics don't change.
How do you think, like the writer of Genesis, would receive all this information?
Well, it tells us in 1 Peter 1, verse 12, that these are being inspired. They also long to understand.
You're glitching again.
It was for a future generation.
Yeah, you might have to repeat that because your audio broke up at that moment.
Oh, sorry. Is that 1 Peter 1:12? These holy prophets of old knew they were being inspired by God and longed to understand what they were recording, but they had to be content. This was for a future generation. And Paul says even angels long to understand what's recorded in the Bible. And we need to realize God inspired the Bible for all generations and expects that subsequent generations would understand more than previous generations. And you see this with Bible prophecy. A lot of the prophecies about the Messiah were not understood until Jesus actually fulfilled them.
That's right.
Hugh, just getting back on topic, what would you suggest we should personally do in regard to climate change?
Well, I would suggest we look for the win-win solutions.
Yeah.
Things we can do to stabilize the climate that at the same time would enhance the world economy rather than cripple the world economy. And give priority to those things that will enhance the world economy, particularly for the benefit of the poorer nations of the world. So, and what's interesting, those are the least expensive ones to bring about.
We live in Adelaide and we're very ordinary people. What do we do?
What can you do? Well, I think you could encourage this whale research that's being done in Australia. Let's do what we can to bring the whales back to where they were. And you know, one reason why we almost wiped out the whales, whales really love human beings. And so during the whaling era, these whales would swim towards the whaling boat and get killed off. They were not afraid of us. And you know, I've got cousins in Canada who've had wonderful experiences with whales. And so to me, it's a shame that we're killing off these creatures that so enjoy fellowship with us. I mean, for example, I have a cousin on Vancouver Island, and he was in a one-man rowboat, and he told me this 50-foot gray whale came right up beside his boat, almost capsized him. And the whale just stood right beside his boat And then he started stroking the whale and realized the whale wanted to be stroked. And so he kept that up for a few minutes. And he said the gray whale disappeared. And so he just started rowing his boat, but then the gray whale came back with his calf and pushed the calf up so the calf could be stroked as well. Here's this huge creature that really was hanging around human beings. And, you know, we in North America wiped out the passenger pigeon. It was the most populous bird species on the planet. And the reason we wiped them out is that these birds so loved contact with humans that no matter how many of them we killed with our shotguns, they just kept coming towards the hunters. And in the space of 30 years, they were completely wiped out. To me, that's a real tragedy. You know, God designed these creatures to fellowship with us. And look how many of them we've killed off.
I think we'll wind it up at this point, but Hugh, thank you so much for coming to, or not coming, but speaking to us. And we're kind of on the southern part of Australia and in Adelaide, isolated from the rest of the world. And it's we're grateful that you take an interest in us. So
Yeah.
You're very welcome.
Yeah.
I've been to Adelaide, but I've been to Perth, I've been to Melbourne and parts of Tasmania.
Yeah.
Yeah. And I've been to all the big cities except Adelaide.
Yeah. Yeah. Well, Adelaide is right up there in terms of a place to live.
Yeah.
And so we are quite proud of it. But yeah, so thank you so much. It's been really interesting, and I can absolutely guarantee that you gave us something to think about.
Good.
And also, just it's kind of overwhelming how much you know, and but we're trying.
There's a lot I don't know. One of the things that frustrates my wife, I'll answer the phone and she says, "Who called?" And said, "I don't know, I took care of it." It just goes out of my mind like that.
Yeah.
But if I read a journal, I can remember it for 30 years.
Sorry? What was that?
When I read a scientific journal, I can remember it 30 years later.
Oh, I thought you said something about girls, but never mind. Yeah, all right. So, yeah, so thank you very much.
Very welcome.
And we'll be in contact with your contribution.
Right.
All right.
Thanks, Hugh.
Thank you.
Bye.
See ya.
Pleasure.
Bye.
Hugh,
Did
I'm
you?
just a child. I don't know what I can do.
Oh, okay.
She's coming.
Hey.
She said she's a child. She doesn't know what she can do. Well, one thing you can do is grow up, but
Not helping.
all right. Would you like to answer that, Hugh?
I think one thing we can all do is just share this message with more people.
Yeah.
As I engage people in climate change, they have no idea that there are things that we can do to stabilize the climate that benefit the economy. I mean, just knowing that, because people are frustrated by how political this has become. I know it's political in Australia, and it's political all over North America. Wouldn't it be wonderful if we can get the politics out of this whole thing?
Yeah.
The way to do it is say, look, we're not between a rock and a hard place. There are multiple win-win solutions. So just getting that word out, I think, would make a big difference. And you know, wouldn't it be great if all the politicians can agree?
It's just last time I tried something like this, a lot of the kids in my class tried to oppose what I said.
Well, you probably need to get some people around you. You know, I found that being a single voice doesn't work. You really need to get a coalition of people. And so, you know, just as we spread this message amongst one another, I mean, that's why I wrote the book. It's basically, I need to get more people thinking about this. And unfortunately, this pandemic has really blunted interest in climate change. But hey, this pandemic's not going to last forever.
I'll always follow your curiosity anyway. It's great that you're heading in this direction.
That's right.
Thank you.
Be curious on purpose. Okay.
All right.
I guess I could.
See ya. Bye.
Bye-bye.
I guess I could talk to the 3 friends I have in my class.
Yeah. Okay, we'll leave it there.